Hey, Algebra 2, Chapter 1, Section 1-4, we're looking at solving absolute value equations. And so these are going to be equations with the absolute value in it. When we talk about absolute value, we're talking about the distance a number is from 0. So if we think of the number line and we consider values that are, let's say, 3 spaces away from 0, we could be talking about positive 3, which would be here, or negative 3, which would be here. So when you write something like, hey, the absolute value of x is equal to 3, what you're saying is that the distance this number is from 0 would be 3 spaces. In this case, recognizing that there's only 2 choices tells me that x is either equal to a positive or a negative 3. Or I could write that out as x is equal to the set of 3 and negative 3. All right, so that could be a possible answer for this problem. Well, that is the answer for this problem. And so when we're looking at some problems, I want you to also keep in mind the fact that absolute value often introduces the opportunity for 2 distinct separate answers. Anytime we talk about absolute value, we also have to keep in mind that sometimes there are values that aren't going to work. If I said that the absolute value of a number is, let's say, -7, this should raise alarm because we never measure distance in a negative context. So in this case, we would say no solution. There's no answer here. Or even better, we would say that the answer is the empty set, which can be written like that, or it can be written with set notation with nothing in it, which is the empty set. So the empty set implies that there's no answer that'll work. The only answers that'll work are non-existent ones, and so we would use the empty set. Let's go ahead and look at a first example. So today we're going to evaluate this particular absolute value problem. And one thing that students sometimes do is they see absolute value and they think of it as a magic make a positiveinator. So if you had something like 3 minus 7, I often see students who would say, oh, that's 3 plus 7 because we can't have a negative. And that's incorrect. These are not equivalent. When you have absolute value, what you are required to do is treat it almost as if those are parentheses. You do what's in the parentheses and then you deal with the idea of absolute value next. So in a problem like this, the absolute value of 3 minus 7, I would calculate 3 minus 7 to be -4, and then I'd take the absolute value of that. The absolute value of 4, or the distance that 4 is, -4 rather, is from 0 is +4. So in that way, I'll make the answer positive. Let's keep that in mind when looking at this problem here. So for this problem, we are substituting in a value for y, and that value is -3. So I have 1.4 plus absolute value of 5 times -3 minus 7, and we want to figure out what this is. We're not going to make things positive yet. What we're going to do is actually simplify what's going on, treating these absolute value bars as parentheses. So this is really 1.4 plus the absolute value of -15. That's me multiplying these two, minus 7. Continuing on with our theme, I've got to simplify what's going on inside the absolute value bars. So that's going to stay there. -15 plus a -7 is going to give me a -22. So now that I've simplified this down to one number, I can take the absolute value of that number. What's the distance -22 is from 0? Well, it's 22 paces. So it's 1.4 plus 22. And so what this tells me is that my final answer is really just to add these two together, and I get 23.4 as my final answer for example 1. Let's look at example 2. In example 2, we're actually solving this equation, this absolute value equation. As we mentioned before, if I have the absolute value of x equaling 3, I recognize that this implies 2 possible values for x. X could be -3 or x could be +3. I keep that in mind whenever I do a problem like this. So in this case, the absolute value of x minus 18 equaling 5 tells me that all of this stuff up in here, right, can be two things. It can be either x minus 18 could be either a +5 or a -5. So what this tells me is I ultimately have two different problems when solving absolute value equations. So I've got one where x minus 18 really could be negative 5, or another situation where x minus 18 could be positive 5. I'm going to solve both of these and get answers for this inequality or this absolute value equation. Adding 18 to both sides, these guys cancel out. I get that x is equal to 13 here. And over here, adding a positive 18 to both sides is going to give me that x equals 23 is another solution. When I plug these solutions back into the equation, I see that they both work out fine. So x is the set of values, 18, oh, not 18, sorry about that, set of values 13 and 23. So that's the solution set for this inequality. Sometimes we could have no solution, as we will have here in example 3. In example 3, it reminds us that when we solve inequalities, we need to isolate, I keep saying inequalities, my bad. When we solve absolute value equations, we need to isolate the absolute value. That means get this guy by itself and push everything else to the other side. When I do that, I'm going to see something interesting happen. So I've got the absolute value of 5x minus 6 plus 9 is equal to 0. I'm going to isolate it by adding a negative 9 to both sides. So I'm left with the absolute value of 5x minus 6 equals, because these guys cancel out, a negative 9. This should raise an alarm. No absolute value will equal something negative because we can't talk about the distance from 0 as a negative thing. So at this point, we can also see that we have a no solution situation. No solution, or the answer is the empty set. As we know, we can write it in two ways. Number 5, nope, example 4. Sorry about that, I'm pushing us ahead. Or do we even, I don't even think we have an example 5, so I don't know what I'm making up here. But anyway, example 4. Sometimes we will get situations with one solution. As we see in this problem, the absolute value is already isolated, which is pretty cool. So now we have to consider what this means. So we said last time that when we have an absolute value situation, this thing inside here could either be the positive version of this answer or a negative version of this answer. So again, we're going to have to think about those two possibilities. So this could either be positive 3x minus 2 or negative 3x minus 2. I'm going to write the positive one over here to the right. So positive 3x minus 2 or negative 3x minus 2. That's what this can equal. So I'm going to go and actually work on those two problems I just created. X plus 6 is equal to negative 3x minus 2, or x plus 6 is equal to positive 3x minus 2. And so I've got two equations to solve, but I can handle it. Noticing that there's a negative out here, I've got to distribute that negative. I actually think of it as a negative 1. If I distribute negative 1, what I end up with on the right side of this equation is a negative 3x plus 2. And then on the left side, I've got x plus 6. Solving this like I would, I'm going to move my x terms over here, my constants over here. I'm going to add 3x to both sides. As I do that, I get 4x plus 6 is equal to 2. I'm going to get rid of, since I only want x terms here, I got to get rid of this 6. I'm going to add its opposite to both sides. So I get 4x is equal to negative 4. Therefore, when I divide both sides by 4, x is equal to negative 1. This is one possible answer. And I'm going to check it later on, but it looks pretty good to me, all right? I have to check my answers, make sure everything is good. Let's check out this guy over here. If I'm going to solve on this side, I'm actually going to put my x's over here, and I'll put my constants on this side. And when I do that, since my constants are staying, this x has to go. I'm going to add the opposite of a positive x, and I get a negative x. I get that 6 is equal to 2x minus 2. Since I only want x terms here, this 2 has to go. I'm going to add its opposite. Since it's a negative 2, I'll add a positive 2. I'm left with 2x is equal to 8. Finally, x, if I divide both sides by 2, is equal to 4. x equaling 4 is the other answer. Now the question is, do both of these work? And that's why we have to check to make sure that both of them do work. So if I go back to this problem, if I have the absolute value of -1, I'm trying out this answer here, plus 6, is that the same thing as 3 times -1 minus 2? And you might be seeing that it's not, and I'm seeing that as well. -1 plus 6 is a +5, absolute value of which is just 5. So this whole left side boils down to 5. But over here, 3 times a -1 is a -3 minus 2, and -3 minus 2 is -5. Clearly they don't equal, so this is not a solution. Okay, let's come over here and take a look at what's going on. So on this side, x is equal to 4. I'm going to plug 4 into this original equation. Let me do it up here. 4 plus 6 should be equal to 3 times 4 minus 2. Let's see what happens. 4 plus 6 is 10. Absolute value of 10 is 10. So I end up with 10 on this side. Over here, I get 12 minus 2 because 3 times 4 is 12, and 12 minus 12 is 10. Woohoo! It works. And so I see that this is a legit answer. So here we got one solution. It started off seeming like we might have two, but we only ended up with one solution. So when I tell you that absolute value means that you'll have a possibility of two solutions or two answers to your equation. It's just a possibility. As you saw, in this example we had one, in this example we had none, and over here we had two. Remember when you are working on your problems that you need to simplify everything within the absolute value bars, treat it like a parentheses, and then apply the idea that when you get your final answer, you know it has to turn to a positive. With that in mind, that is it for us. We have some problems that I'd love for you to work on. I'm going to ask you to turn to page 30 and 30, work on pages 30 to 32 in your text, and do page number 17 through 47 odd, and these bits here 50, 51, 53, 68 through 72. Please let me know if you have any questions. Answers will be coming soon, and I look forward to talking to you soon. Bye-bye.